catalysts are of huge importance in the chemical industry, and lots of people spend a lot of time working out which is the best to say. What does a catalyst do? A catalyst speeds up a rate of reaction, but doesn't get used up itself. We look at in A2 chemistry more what a catalyst actually does. At AS, all we're going to think about is it doesn't get used up. How does that work? Well, again, if we go back to our party model, I think you can kind of explain it that if you've got a mixture of you guys, a catalyst is like the ultimate party host. So a catalyst, which I will put in blue, you don't need much of it. So here is my catalyst here, like the party host. He'll go up and you go, oh, I know someone I think you're like, you know, why don't I introduce you? He takes you over to said person, introduces you, you get it on, but walks off, okay? Has anything happened to the person hosting the party? Have they? No. They're back to how they were. They go off to another club and go, oh, I think I know someone you'd like, you know, I'll take you over, I'll introduce you. So they lower that activation energy, because you know how difficult it is. The worst thing is approaching someone and actually going, hello, I quite fancy you, why don't we get it on? Really tough. However, if you've got that person who knows both of you, the ultimate matchmaker, they can get that to work. Leads a very sad existence, because the matchmaker ends up being alone at the end of the night. However, they get their satisfaction from knowing that they have managed to match a lot of people together. So themselves are unchanged, however, everybody else they've managed to link up. So they've had lots of successful matches. Like so, they're all happy, but the catalyst is unchanged itself. So a catalyst lowers the activation energy. It lowers that energy needed for successful collision. Okay. So a catalyst increases the rate of reaction. But is not used up at the end of the reaction. It is unchanged. They work by providing an alternative route for the reaction. Which has a lower activation energy. So, what they often want you to do is draw it on an energy enthalpy profile diagram. So, the way you do that, I'll do it for an exothermic reaction. Get your axes sorted. So, we've got reaction coordinate there. And we have enthalpy there. So, if I've got my reactants there, and I'm going to put my products down there. That is delta H, which is negative. So delta H is negative. In red, I'll put the activation on it. So activation in red, that is without a catalyst. So I'm going to call that EA without catalyst. In blue, I'll put it with a catalyst. So my activation energy is lower. So it only has to go a smaller hump like so. So my blue arrow is EA with catalyst. Has delta H changed at all? Delta H is unaffected. The only thing that's changed is activation energy. So they often want you to show that. So show on an enthalpy profile diagram the activation is without a catalyst and it with a catalyst as well. So make sure it's clearly labelled. Remember on your exam paper, colours won't come through. So just label it really clearly. That's EA with a catalyst, and in red, that's without a catalyst, like so. So it's nice and clear for them.